So you can have these incredibly powerful servers, right? And dozens of virtual machines all humming along. But you know what? None of that matters if they can't actually talk to each other. Today, we're going deep on the one piece of the puzzle that makes it all work, the Hyper-V virtual switch. Think of it as your server's very own digital traffic cop. I mean, really think about it. You've got all these virtual machines, or VMs, that need to chat. The main server hosting them has to be in on the conversation. And of course, they all need some kind of path to the wider world. The internet, your company network. So how on earth do you manage all that data flying around without it just becoming a massive digital traffic jam? Well, the answer is this really clever piece of software, the Hyper-V virtual switch. Now, at its heart, it's a layer 2 switch. All that really means is that it's super smart about directing traffic based on the hardware addresses of your VMs. It's just like a physical switch you might have in a server rack, but it's all happening inside the software. Its entire job is to be that traffic cop, making sure every single packet of data gets exactly where it's supposed to go, no questions asked. Okay, so what's the actual job description for this digital traffic cop? Well, its role is absolutely fundamental. It manages 3 supercritical communication pathways that are basically the backbone of any virtual setup you can imagine. First up, it lets your VMs talk to each other. You can think of this as, say, the traffic between different buildings on the same corporate campus. Second, it connects all those VMs back to the host server itself, the main headquarters. And third, it opens up that all-important gateway to the outside world, letting your VMs merge onto the public highway we call the internet. But here's the thing. Not all traffic needs to go to the same place, right? And that's where the real power comes in. Hyper-V gives you 3 totally different types of switches, and each one creates a unique path for your data. Picking the right one is absolutely critical. And here they are, the 3 big choices. You've got your external switch, which is all about connecting to the outside world. Then there's the internal switch, for when your VMs just need to talk to the host server they live on. And finally, the private switch for a totally sealed-off, secure environment. The choice you make here has a huge impact on what your apps can do, and maybe more importantly, how secure they are. Let's start with the most common one, the external switch. This is your on-ramp to the information superhighway. It literally links your virtual switch to a physical network card plugged into your server. This is the one you're going to use most of the time, because it gives your virtual machines a direct line out to the physical network and the rest of the world. Next up is the internal switch. You can think of this one like a local service road. Imagine you're building a new tool just for your company. You want your VMs to talk to each other and maybe grab some files from the host server, but you definitely don't want it accidentally exposed to the internet. That is the perfect job for an internal switch. And finally, we have the private switch. This is the cul-de-sac of your virtual neighborhood. When you use this, you're creating a network that is totally and completely isolated. Only the VMs on this switch can talk to each other. The host can't even get in. This is the absolute gold standard for security, especially for things like a web server that only needs to talk to its database server and nothing else in the entire world. So if you're ever trying to decide between internal and private, it really just boils down to this one simple thing. Is the host server part of the conversation or not? With an internal switch, the host gets an invitation to the party. With a private switch, it's completely locked out. That one little distinction is everything when you're designing for network security. Okay, so basic traffic direction is cool and all, but that's just scratching the surface. With Windows Server 2025, our little digital traffic cop gets some serious upgrades. We're talking superpowers that let you really supercharge your virtual network's performance and its reliability. The headline feature, the one that everyone's talking about, is something called Switch Embedded Teaming, or just SET for short. Honestly, this is a total game changer for getting the absolute most out of your server's hardware. So how does this magic work? Well, it's actually pretty simple. You take 2, 3, maybe 4 physical network cards in your server, and SET lets you bundle them all together into one single super powerful virtual switch. This means you get the combined speed of all those cards, and if one of them ever fails, no big deal. Traffic just automatically keeps flowing through the others. It's a speed boost and a safety net, all rolled into one. And the fine-tuned control gets even better. With VLANs, you can basically create dedicated express lanes on your network, keeping traffic from your finance department's VMs totally separate from your marketing teams. Then you've got access control lists, or ACLs, which are like security checkpoints. You can write specific rules, like let the web server talk to the database, but block it from ever touching the file server. And with Network HUD compatibility, you get this amazing live dashboard to see how everything's performing in real time. All right, now even the best traffic cop has a rule book. And before you dive in and start setting all this up, there are a few key things, some considerations and limitations you really need to know about to make sure everything runs smoothly. So first off, you'll be managing all this using either the nice graphical Hyper-V Manager, or if you're a command line fan, the incredibly powerful PowerShell. Second, and this is important, keep in mind this whole system is for Ethernet networks only. No other network types are supported. And finally, while the Hyper-V feature itself is free, you've still got to have the proper Windows Server licenses for both your host machine and any virtual machines you run. So after all this, why does this one component matter so much? I mean, it's just a switch, right? Well, no. It's so much more than that. Because the virtual switch isn't just another feature on a list. It is the absolute bedrock, the foundation of your entire virtual environment. You know, there's a line from the source material that just hits the nail on the head. It says, virtual switches act as the bridge between the virtualized environment and physical hardware. And that's exactly what they are. Without a strong, stable bridge, nothing gets across. Ultimately, what it all comes down to is this: understanding how to pick the right switch, how to configure it, and how to manage it. That's the secret sauce. That's what lets you build virtual networks that aren't just working, but are powerful, incredibly secure, and super efficient. It all starts right here. And that kind of leaves us with one big final thought to chew on. As virtualization and cloud tech just keep evolving at this insane pace, the demands we put on the digital heart of our network are only going to get bigger. So the real question is, what's next? What new intelligence, what new capabilities will the next generation of our digital traffic cops need to have?